Walk into any modern home after a long winter, and you may notice sagging rafters, damp attics, or even visible rot in roof timbers. It seems almost inevitable that cold, snow and ice will slowly destroy your roof. Yet step into a medieval hall, a Viking longhouse, or a Depression-era farmhouse, and those same elements barely leave a mark even after centuries. The reason isn't luck. It's ancient timber techniques that modern builders have largely forgotten. Today we're uncovering why most modern roofs fail in winter, and the simple ancient timber fixes you can copy to dramatically extend the life of your roof. Before we dive in, subscribe to the channel and stay with us, because this is practical, time-tested wisdom you won't find in standard construction guides. The first reason modern roofs fail in winter is, well, a misunderstanding of how wood reacts to moisture and temperature. Wood expands when it absorbs moisture and, contracts when it dries. In winter, snow and ice introduce these repeated wet-dry cycles, and indoor heating causes rapid temperature swings. Modern timber is often kiln-dried rapidly and then sealed with plastic coatings or membranes. While this seems protective, it actually traps stress within the wood. Small cracks form internally, invisible at first, and these become moisture traps. Over time, rot accelerates and structural integrity declines. Ancient timber was selected with environmental resilience in mind. Builders prioritized slow-grown trees with tight grain and high resin content. Winter felling was, the standard practice, as it removed sap and reduced the internal sugars that would otherwise feed fungi. Then timbers were air-seasoned for months or even years, allowing the fibres to settle naturally. The result was wood that could expand, contract and breathe without fracturing. To apply this today, you should seek out dense, slow-grown timber for structural elements and allow it to acclimate slowly to the building environment before installation. Even a few weeks of adjustment can, honestly, reduce stress and increase winter durability. Another critical difference lies in roof geometry and load distribution. Ancient roofs were steeply pitched to shed snow quickly, preventing prolonged moisture exposure. Rafters were, sized generously, joined with pegged or interlocking joints that allowed movement under load, and installed with intentional gaps for airflow. Modern construction often favours shallow pitches, thinner engineered wood and tight connections. Snow sits longer, water drains poorly, and trapped ice can exert enormous force on weak joints. By increasing roof pitch where possible and designing joints that can move slightly rather than resist, you allow snow and ice to pass without compromising timber. Ventilation was, really, an integral part of ancient timber wisdom. Roof cavities were never airtight. Gaps at the eaves and ridges created passive airflow that expelled moisture and prevented condensation. In modern homes, tight insulation and sealed cavities tend to trap humid air from heating systems, which in turn leads to internal condensation. By ensuring ridge vents, soffit vents, or even small passive gaps along timber lines, moisture can escape naturally, just as it did in those medieval and early modern roofs. This really prevents rot before it starts. Surface protection complemented all of these measures, you know. So, ancient builders often used pine tar, light charring, or oil-based coatings to shield exposed timbers from water, while, you know, still allowing them to breathe. Modern paint and membranes can seem protective, but honestly, once they're breached, they trap moisture inside. A breathable, water-repellent finish on structural timbers can keep wood dry, while at the same time accommodating natural expansion and contraction, which in turn greatly reduces winter damage. Load distribution and joinery are, well, another ancient lesson. Pegged joints, interlocking beams, and scarf joints allowed wood to flex under the weight of snow and ice. Metal fasteners were minimized to avoid those pesky localized stress points. These days, modern roofs rely heavily on nails and screws, often in thin boards or engineered panels. The result, unfortunately, is stress concentration, cracks, and hidden moisture channels. Using traditional joinery principles, allowing timber to move under load, can, you know, dramatically increase the life of roof structures, especially in harsh winter conditions. The final piece of the puzzle is observation and maintenance. Ancient builders inspected timber frequently, repaired minor damage promptly, and understood that wood is a living, changing material even after felling. Modern construction often ignores early warning signs, waiting until significant rot has set in. Adopting the old mindset, looking for moisture accumulation, sagging boards or surface wear and addressing it immediately, can prevent minor winter stress from turning into catastrophic failure. Applying these lessons doesn't require building a Viking longhouse from scratch. Just start with dense, slow-grown timber. Where possible, let it acclimate properly and protect it with breathable coatings. Make sure your roof pitch lets snow and ice shed efficiently. It's important to maintain airflow through ridge and soffit vents, and, you know, consider joinery that allows for movement instead of locking everything rigidly in place. Keep an eye on your roof over winter and address any minor damage as soon as you spot it. Every step here borrows from centuries of proven timber practice. If this guide has given you a fresh perspective on winter roof durability and ancient timber wisdom, do subscribe to the channel and share this episode with someone who's frustrated by winter rot. Relic logic exists to uncover why older building systems lasted. Not to romanticize them, but to recover knowledge that lets us build smarter and stronger today.